All right, hello, my wonderful students. This is part 3 of foldable number 6. We have our another and inequality compound. So and compound inequality, so it's going to be both. Put that back over. We have our first inequality is negative 6n is greater than negative 60, and n over 9 is greater than or equal to negative 1. So we're going to go ahead and start off with the equation on this side, with the inequality on this side. And we're going to see that the negative 6 is actually affecting the n. So we're going to solve for the n by dividing by negative 6 and dividing by negative 6 on this side. Negative 6 divided by negative 6 divides to 1. 1 times n is n. Because we divided by a negative number, just as we showed earlier, we're going to flip the inequality. So it's no longer going to be greater than, it's also now going to be less than. And then we have our negative 60 divided by 6 gives us our positive 10. So this is our division property. And it's also going to be the property of inequalities. Because the properties of inequalities says if you divide or multiply by a negative number, you flip our signs. Okay? So now go ahead and we solved this one already. So we're going to go ahead and work out this one now. So for this one here, we're going to multiply both sides by 9 or 9 over 1 in order to get rid of the fraction. So this is going to give us our 9 times n over 9, which means we can go ahead and divide both of these out. So we have 9 divided by 9 is 1, which leaves us just with n, because 1 times n is n. And it's greater than or equal to negative 1 times negative 9, or sorry, negative 1 times 9, which gives us a negative 9. And this is our multiplication property. Multiplication property. So this one we did not need to flip the inequality because our 9 that we multiplied by was positive. So remember that only happens here when we multiply by or divide by a negative number. Okay, so let's go ahead and draw out our graph. Let's do it here. Nice and big. Shouldn't do this big, but it's okay. It's funsies. All right, we're going to go ahead and put our negative 9, put our positive 10, and we're going to add 0 somewhat in the middle. Slightly more to this side because the negative 9 is closer to 0 than it is to 10. Alright, so we're going to go ahead and graph these. So let's go ahead and do this one in this bluish color. So we're at 10 here, and it says n is less than 10. So we know we're going to shade to the left because to the left is less than. But we're going to leave 10 with an open circle because it's less than and not less than or equal to. Okay, now we have this one over here. We're going to do in pink. I fancy the pink today. I don't know why, but the pink's looking out pretty good for me. So we have n is greater than or equal to negative 9. So we're going to go ahead and put a closed circle here. And then we're going to go ahead and draw our line to the right because greater than is to the right. All right, and then we can go ahead and see that. Let's use this purple color. This here is shaded open here on this side, and it's closed on this side, and we're going to shade the middle inequalities. Okay, so once again, this is an and statement. So and means that a solution makes both inequalities true. Kind of want to show you something with my hands real quick. So whenever you have an and, say you have two inequalities, they're always going to be like this, facing this way. So facing this way here. So kind of draw little hands over here just as a reference. But if whenever you have an and inequality, excuse my drawing too, because it's going to be kind of weird. That's the hand pointing that way, and then the other hand pointing this way, and this is an and. Okay, so the two fingers kind of point this way, just like we did here. So this side is pointing this way and this side is pointing this way.